Yesterday we did deploy that smart contract, remember? At this address. What was the name of the chain that we deployed at? Sepolia what? Sepolia Arbitrum, right? If I look for this address into the Ethereum Sepolia, we are going to find something there. Ethereum Sepolia. Remember, Ethereum is a protocol, and we have many implementations. For example, Sepolia from Ethereum testnet. We have here, actually we do have one transfer here for this thing, for this address, but there is no contract deployed here. So some random person transferred here. But if we look for that into Sepolia Arbitrum, we are going to find that this is a contract. Here, contract. Okay. Did we write those bytes ourselves? By hand? What we used to come up with those bytes? Yeah, it starts with a C, a program, a compiler, yes. We used a compiler that is inside the IDE. You all answered correctly. And when this program is stored in the blockchain, when we pass some inputs to it, it can compute some outputs inside of the blockchain. Remember? Let's see what happened in this transaction here. So we passed this input, and somehow something, 3 letters, made it possible to compute this output. So a number that it was 0, change it for 42. What is that thing that made this possible, those 3 letters?
EVM.
The EVM, Ethereum Virtual Machine, remember? A lot of names, you don't need to remember them all at the top of your head. It's just that the more we say them, eventually you are going to get used to it, okay? Bitcoin has an EVM there. Do you know? The Bitcoin blockchain has an EVM there?
No.
It doesn't?
They're going to try.
Taproot and all of that, but exclude this. So not all blockchains have an EVM there. The EVM allows us to use smart contracts, and this is all about what we're going to learn in this bootcamp, okay? This is important to give a glance of the whole world. Instead of studying the whole world, we are looking at Europe, and inside of Europe, we are looking at France, or Italy, why not, or Switzerland, in the middle. So did you position yourselves, where we are, what we are dealing with? And this smart contract transaction here is totally different for the code that you do for other things. It's not an executable. It's not something that you are going to run in the terminal, okay? It's very important to make this distinction, because if we start to develop thinking that this is a common code that you're going to execute, you're going to be very confused, because things work totally different than what you are used to. So let me open here Remix. And return to the smart contract we were using. We didn't go deep into the syntax yet to know exactly what are each things, but we are understanding the structure of a smart contract, what it can do, what it cannot. Okay, this is why you are a little confused, probably, because you still don't know what each line do, but you are grasping the concept of the things, right? Something like this. Okay. So when we compiled it, it became a bytecode, and when we deployed, it's now stored on chain. We can call things on it. Remember? So for example, I'm going to start with the virtual machine environment. That is very handy for us because it has a set of features to make our lives easier. Do you remember what features are those? For example, it has some pre-funded. Do you remember? It starts with an A. Pre-funded wallets, pre-funded accounts. Remember? So we are rich. No, fake money. So it has those pre-funded accounts. What else? Another advantage of using this virtual machine environment.
Very fast.
Very fast. You click, it deploys. For example, click, deploy. Deploy again. Again. Did you see it? Again. Okay. So we have deployed 4 contracts here very quickly. Okay. What is the disadvantage?
It's only on your laptop, on your browser.
Only my browser. Remember? So it's good for trying out quick things. So for example, I'm going to deploy one smart contract like this, and I'm going to call a function retrieve, for example. And we have 0 here. Okay. How to execute the whole contract instead of just calling the functions? You remember?
Not possible.
It's not possible. That's not the design of a smart contract. You can make a script to call everything, but it's like a vending machine. You still need to pick an option and interact with it. Okay, it's very important. Hey man, you joined us today. That was good. From the last bootcamp. So this is how smart contracts work. You don't execute them all. You execute function by function. Okay. So let's start to do hands-on. Let's start to use it and perhaps even break it. I'm going to connect to my MetaMask. Remember this step from yesterday? This is going to connect me to the public blockchain. It's not inside my browser anymore. So I'm going to connect this application called Remix, this IDE, to the public blockchain using my MetaMask. And I want to interact with this same smart contract from yesterday. This same smart contract here. Yes, question?
Why the signature on MetaMask is free? Doesn't send data or transaction of any kind.
Free, you mean
I don't pay anything for sign and say, okay, I want to use a Remix.
Yeah, you don't pay. When you pay, that's an important review as well. When you pay for including a transaction in the blockchain, you are paying for compensating someone else's work, right? The miner, the validator. Remember that from yesterday, people? When you are including a transaction in a block, you are paying for that. When you are connecting MetaMask with Remix, you are not changing anything in the blockchain yet, you see? You didn't send a transaction. When we send a transaction, for example, a deploy transaction, then this would have a cost. For example, $7 fake here. Yes?
What does it mean to change environment? Weights and environment?
Yeah, so for example, we started with the virtual machine environment. That is very fast. We have pre-funded accounts, but it only works in my browser. And now I changed it for MetaMask, another choice of environment that is the real thing. It spends real fake money, not fake money, you see? Yeah, I know it's confusing, but there are 3 degrees of fake money. The fake money, like the virtual machine. The real fake money that is in a public blockchain, but you can mint it into the faucets. And weak currencies like Brazilian reals. Okay, 3 kinds of fake money. So, just kidding. Oh no. This is the difference from those environments, okay?
By connecting to a different chain.
A different provider, because MetaMask can connect you to different chains as well. You can come here and change for mainnet, for example. Okay, so imagine like gateways. What's your gateway to the blockchain? Okay, and here I'm seeing my account that I have this balance, and I can deploy a new smart contract. Okay, But in the last minutes of yesterday's lesson, I have shown you how to connect to a smart contract already deployed. Do you remember how to do that? Sorry? Here? Okay, so what I do? You paste? Here? Okay. Oh, I click deploy. Are you sure? I really want to click deploy. Just kidding. Add address. So this is not going to send a transaction. Okay. You get that? It doesn't send a transaction because the smart contract is already there. We didn't change anything in the blockchain. If we click deploy, then it's going to create a transaction. Okay? But even if I deploy, I'm going to get a new address, a new smart contract. In one smart contract, I can have like 42. In the other, I can have like 30 storage. Those are different storage in the blockchain. Okay? So by clicking add address here, now I can retrieve the value that is 42, and I could potentially change it for something like 99. And when I send this transaction, it goes for the blockchain. I need to pay for it. I need to bribe a block producer to include my transaction in the next block or in some of the next blocks. Okay? No one's going to work for me for free. And if we, let's stress this, if we give a look on that transaction, let me see this smart contract again, I'm going to see a list of transactions. If I give a look on that transaction, it's that same process. I've sent some data in form of bytes here. This was processed inside the smart contract in the EVM, and it produced a state change from this number to that number, like a database. Okay? And also it processed a payment that my balance reduced a little for paying the gas for that transaction. Okay? So it mixes the logic of the program with the persistence, like a database inside. One single line of code, this line of code 12 that created a state variable, is mixing a variable and like a database entry. It has like a persistent relationship. Okay? This is different from other programming languages. You usually need to code this in your code for it to happen. Good. Now it is your turn. Connect to that smart contract and make a number change here. Let me see the numbers. Let's see if you can break this contract. Let's see who gets the biggest number stored here.
I have some problem making the address because he's saying that the contract is not concurrent. I have a contract when I go on the...
Okay, it is really quick to solve. You just need to select the storage.sol here, and then you go and click compile, or you can even check this auto-compile that makes your life easier. Every time you open a file or change a file, it auto-compiles. And then you can attach here. Also remember to be in the Arbitrum Sepulha testnet, otherwise you're not going to find that contract. Okay? Remember that it is in MetaMask. You need to choose this network. If you don't have that network, just remember you can add it here into the Sepulha Arbiscan in this button. Okay. So let's see who can get the biggest number, the highest number stored in that smart contract. Okay, let me retrieve 999. Someone beat me. Who can get higher than that?
To connect to the smart contract, I have only to use the address and click on at address.
Yeah, but check if you are using MetaMask, if you are connected to Arbitrum. Yep.
To put the high number.
Let's see how high you can get. $256. 256 is lower than 999. I guess we need to give a prize to cure your curiosity here. You see what's happening here? A lot of people is able to interact with the same smart contract. While you test that, let me spark some discussion here. Did we buy a license? Did we pay something? Did we receive an access code? Did we register to that software? Did we download the code? The only thing that we need to do to use that software is send a transaction.
The network is a beacon Setolia test network.
Yeah.
I put so much you
What is the maximum you need?
2 at the power of 2, 5, 6, minus 1.
Minus 1. Yeah, that's the maximum.
Plus 1 and it breaks.
Yeah.
Okay.
Just be right back. Yes, you have a question? Raise your hand. Okay. Yes. Arbitrum Sepolia, yes.
So I connect with that. I go on Linux, I inject provider,
Yeah.
and then the rest of the contract, and
Did you copy it correctly, perhaps?
I hope so. It was this one.
Yeah.
This one.
Well, I'm going to quote IT crowd, like the IT crowd. Have you tried turning it off and on again?
What?
Have you tried turning it off and on again? Like close a tab and open a new tab.
Come me lo fa fare?
Environment first. That's weird. Paste that in Arbiscan just to see if you are with the right address. Yeah, that's the right address.
No, non posso fare la transazione perché no. Also, I don't have money on this.
That shouldn't be a problem. What browser are you using? Chrome? Oh, should work. I don't know.
So it's just me.
Probably.
But they say that I don't have enough.
Yeah, so you can get in the faucet.
Yeah.
Let me tell that for everyone. Hey people, if you are out of fake money, you can ask fake money from the faucet, remember? So you're looking for this faucet here, Arbitrum faucet, so you can get free fake money. Arbitrum. So.
Can I ask you a question?
Yep.
Because I had the MetaMask, I had the storage, but if I try to add the address, it won't let me click.
Yeah, that guy's having the same problem. Don't know why. Did you copy it correctly?
Yeah.
If you go for Etherscan, go for Arbitrum.
Here?
There is a link up a little. Yes, scroll a little more. A little more. This link.
This one?
Control C, sorry. Let's just undo that. What you did. Yeah. So paste there, just to see if you have the right content. Yeah, it's correct. So it should work, but
If I do deploy, it connects to my...
yeah.
Not to
Hover up, just make sure down at the blue box.
what? This one?
There is in Chrome, right? It should work. Yeah, but you did compile, right? Go there in the compile tab. Click on bytecode, just here. And paste it somewhere. Yeah, anywhere. Yeah, so you have that correctly. You can undo. You can undo that. Control Z.
Come...
Control Z, yeah. It should work. Don't know why it's not working. That's weird.
Secondo me qua
Sì, è lo stesso esercizio, il problema è che se non glielo fa
cancellare cancelli. Vabbè, ma l'abbiamo già fatto.
Did it work? Work?
Not sure. Tipo, eu criei a parada aqui, eu coloquei o número máximo
Mas
que pode.
tem que... Você modificou o arquivo?
Eu criei um novo.
Não, tem que usar esse storage ponto sol mesmo.
Eu tenho que usar esse daqui.
Esse aí.
E eu tenho que fazer o quê?
Mais nada. É só compilar.
Tá, tem que compilar esse cara que eu já
Isso,
tenho.
vai no deploy. Aí você pode até excluir esses outros contratos. Clica aqui no...
Tá.
E aí...
Esse é o endereço, tem que ser o endereço que tá lá no negócio,
Isso.
né? Tipo aqui. Aí beleza. Aí eu tenho esse endereço.
Isso.
O que eu faço quando eu tô fazendo net address? Eu tô acessando...
Conectando ao contrato.
Conectando ao
Aí
contrato
clica no
que existe.
retrieve. Aí, funcionou.
Mas aí como que eu faço para colocar o número...
Store.
então
Mas qual rede você tá?
eu pego esse número máximo aqui.
Qual rede que você tá no seu MetaMask?
Eu tô na rede Sequoia.
Você precisa estar no Arbitrum Sequoia. Lembra? Hey people, very important. We need to connect to Arbitrum Sequoia. Okay? You can ask money in a faucet. Okay, questions? How's it going?
Sorry, I didn't
No problem.
understand the difference between address and deploy.
Okay, let's review that. Hey people, important review. When we upload the code to the blockchain, it is stored there at an address, at a specific place. Remember, like a street, a neighborhood, you have that address. But instead of having a street and number, we are giving a set of hexadecimal characters. So this is the address. Street, dot, number, dot, neighborhood, dot, city, dot, okay? This is the place where the code is stored. Remember yesterday I mentioned that there are two kinds of accounts, externally owned accounts that are like us, that access the blockchain with the private key, and smart contract accounts. This is an address for a smart contract. The contract is already there. So if we deploy again, if we click on deploy, we are going to create another address, another account with the same code. It's not pointing to the same database location, no. Two different clones, okay, that are going to have different lives. The same code. They are like twins. Like if you like you met a twin. If you shake one's hand, you didn't shake the other's hand. If you married to one, you're not married to the other. You see different entities. The same thing here. This is the same code. They are stored, they are different entities. To connect to the same code we did yesterday, we cannot deploy again. We would create a twin that would start from zero. So the only way for us to access the database location exactly at the same address, it is attaching like this, add address, and then it works. And then we can retrieve information. Okay? Make sense? And did you see that we don't need like an active subscription or whatever? The only thing we need to do is to pick the correct address and send a transaction to it. Then it's enough for us to use it. We don't need to pay, there is no paywall. We don't need to subscribe, create an account first, use a product key or whatever. It is just sending a transaction to that place. It triggers the program. It triggers the execution. So it's completely open. Okay. This transaction, for example, someone was sending this message. 605736 1D000029A that made a state change that the contract used to store this number. Oh, that's a big number. And now is storing 666. You see? F. That's the biggest number you can store in a smart contract. A lot of respect. Okay? And then change it for 666 here. Or the hexadecimal 29A. Okay? So, in the bottom line, all the glory of the smart contracts and decentralized computing and blah, 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 this boils down to, it is just a database with extra steps. Okay? This is, all the smart contracts are doing this. They are changing key values. So, address and the storage address, this is the key, and this is the value. Everything in smart contracts is like this. It's somewhat similar to building things for hardware. Like you have memory locations. All you're going to do is manipulate those memory locations. But after you push the code, it's there. It is embedded. If you want to change a code, you need to go there, pick the hardware again, and write the memory again. The same thing with the smart contract. You push it there, it is there. Okay? The only difference is that after you put, you don't change. There is no way to change the bytecode after it's deployed. Okay? So no bug fixes. If you deploy a bug, it is a bug forever. Okay? Makes sense? This is the structure of a smart contract. I don't have anything else to say about the structure. What we are going to do forward is dealing with the syntax of Solidity, how to build it, how to use the tools around it. I don't have anything else about the structure. So any questions about it, now is the time to ask. Try to wrap your heads around. Okay. You need more time or questions?
If there is a bug in a smart contract, like in for software, like what do they do? Like they fix it and then they deploy a new contract. Like what is the, let's say, best practice?
The best practice is to go cry in that corner because you can't do anything much else. Sorry for the joke, but there are some upgradability patterns that are quite complex, and most of the protocols and all they do deploy with those upgradability patterns. Okay, that are a technique to bypass the immutability of smart contracts. Okay, but for us in this week, in this hackathon, we are not going to see upgradability patterns. We are going to deploy contracts as they are. So let's say you ship a bug, you have a token, and it's buggy. What you could do is deploy another token, convert everyone's balance. You have 100 tokens, so I'm going to burn your tokens and give 100 tokens of the new one. You have 10, okay, so I'm going to burn your 10 tokens and give 10 of the new one, and so forth. So you do a migration. That is possible, and it's very costly. Okay, but it's possible as well.
Yes, I can make the client to pay his fees for the burning and transferring it.
Yeah. The person's not going to be very happy, you imagine, right? Like you write the bug, I need to pay for fixing it, but it can be done as well. Okay? So these are good conclusions about how smart contracts behave. The code is stored there. It's taking a while to load, but the code is stored there for everyone to use, okay? And now extrapolate that. This could be an on-chain game. This could be a ballot for voting. This could be something exploded there.
Yeah, so all my water.
No problem. Explosive water.
Yeah.
We could use that to fuel cars. Okay? The same principles apply to any other smart contracts and the apps that you are going to find out there. Now let's start understanding Solidity syntax with a contract my storage. This is what, now we start day 2. Welcome everybody. This is my suggested path, my suggested roadmap for you to learn Solidity, for you to learn blockchain and all. Break stuff. Put yourself to practice. Let's change here for the virtual machine again, so we don't pay fake money when we break things. And you do that. You create a new file. Let's create a new file here called mystorage.sol. And we can start playing along, okay? Because, sorry?
Instead of MetaMask, what do we have to use?
The virtual machine environment. Because in the virtual machine environment, you have pre-funded accounts, so you don't need to get funds from the faucet, remember? And the transactions are super fast. So it is better for trial and error.
The storage is the same, or do we have to change it?
So I've created a new contract called mystorage.sol. See? So you can click on this button here, create new file, and then you name it mystorage.sol. Why I'm suggesting you to do that? Instead of giving you a lot of content, a lot of theory, what is a state variable, what is a function, modifier, the call, the storage locations and all of that, it's too much for you to remember at 1 week, you see? You would need more time to digest it normally. When you come here to write and you do something wrong,
Can you make it bigger? I cannot see.
okay. When you come here and try and make something wrong, instantly the IDE is going to give you a red line. It's going to underline it. It's going to point you in direction. Hey, you made a mistake. Here's the mistake. But sometimes it's just going to point into some directions. Okay. It's not perfect. Okay. It's not very advisable as well to, for example, use ChatGPT 3 or 4 to guide you through, because it uses outdated versions of things, outdated information. So having a mix of looking at the documentation and implementing things can get you the fastest, the closest as possible to actually building. For example, this weekend that you are going to build and earn $5,000. It's with this process, right? So we should start by writing something. As soon as I write, I already have a red line here. I already have a problem. It's not showing the problem, but here. We expect the pragma import directive or contract interface library structure, whatever. See? The IDE is already helping me. I forgot an important thing about the structure of a Solidity file that I showed you guys yesterday. If you don't remember, that is okay. At least we know that we are missing something. Okay? You don't need a whole lot of explanation to discover that. Okay? So let's do this with me. Open your Remix, your file explorer. Inside contracts, create a new file and name it mystorage.sol, and we're going to start playing with it. It is still readable if I do like this, or just for me to have more space to play along.
If it could be bigger.
Okay, less space to play. Okay. Okay. No problem. Who remembers what's the first line of the structure of a smart contract, of a license identifier? Okay, but even better, do you remember where to look for it?
Where? In
The last contract.
Here. Oh, in the last contract is a clever place. Or you can pick this documentation link here. Let me close the other tabs. Here, the layout of a Solidity source file. Okay. Questions? A cool thing is that a license identifies the first line of all of the contracts, but actually it is just a recommendation. Okay, the first line that is required is a pragma solidity. Okay, for it to be compiled. So if I put a pragma solidity, that is good. Okay, when we compile something without SPDX license identifier, it gives me a warning. Okay? So for example, if I take out this license identifier, okay, it gives me this warning. Hey, the license identifier is not provided in the source file. Before publishing, consider adding a comment for that. Okay? It has nothing to do with the code part, but it's really advisable. Because if someone uses this code to do something, and if they lose money, or if they break some law, or if something is not working, they could sue you for warranty, they could sue you for liability, or for copyright infringement. So publishing code without a license, especially in blockchain, could be very harmful for you, okay? Yeah.
How can they sue me if they don't know who I am?
They could try. They could trace you through your IP. They could knock your house, pretending that they are a pizza delivery guy. Okay, so that is pretty scary. Don't incur those risks. Put a license identifier. Okay. For example, if you publish that through GitHub, Microsoft is going to know. Yeah. Okay. Makes sense? I'm joking, but partially not. It doesn't cost anything at all and saves you a lot of trouble. And then the second line, yes, it is picking pragma solidity that specify a range for your solidity versions. Okay? It's clever to copy from another contract. So if you have this structure in place, you can copy from another contract. So long you know what you are doing, that's not too much of a problem. Okay? This is picking this license identifier, general public license version 3. If you don't know what are the coverages, what are the permissions of that, it's good to research later. But unless you are ready to push some $1 million project, the license changes from Apache, MIT, or GLP are not going to make so much of a difference. Okay? For this bootcamp, this one is good. And for the versions of Solidity, the same thing. We are currently in the version 0.8.24 at the moment. So here we are specifying that anything from the 0.8.2 to recent versions is good. There are breaking changes from those versions. Version 5, 6, 7, and 8, they all had severe breaking changes. They are not so retro-compatible with one to the other, okay? But for this week as well, to get you introduced to blockchain development, it's not that important what each version do, okay? Just beware that when we have 0.9 coming out, a lot of things are going to change as well. And at this moment, you're going to need to stop and study what are the differences, okay? A question here? So, you had a question?
Yeah. What is the difference between GPL 3.0 and MIT?
There are different coverage, different permissions, different words. Ask a lawyer. It's going to give you the full description. There is a good website for checking web source, open source license. Open source license comparison. Here, choose a license. So there is a good comparison for each of those. Okay, and this is the kind of thing, if you ask ChatGPT, it's going to explain you well. Not Solidity. Okay. And now I want to define a contract, my storage. Do you remember the grammar path to declare a contract? If you don't remember, that is okay. Do you remember where to look for it?
Second one.
Second or the third. Both give me this information. In the language grammar, I'm going to go for contract definition, and this is going to explain me the path. I can choose the word abstract or not. Contract, pick an identifier. Okay. We speed up a little. Good. Did I lose anyone so far? Question?
Like the purpose of that. Isn't there already a contract that makes me do the storage, retrieve, and everything like that?
Yeah, I'm going to do some changes. There is, for example, inheritance. My storage is storage, and I could storage. What's the name again? Yeah, storage. And I could import it here. Import storage.sol. That works.
So you have like a copy.
Yeah, but this is another thing that often confuses people. when I'm inheriting my storage from storage, this is inheritance. You might have seen that in other programming languages. You are inheriting the code. It has nothing to do with the deployed instances. See, often people mistake that, hey, if I inherit from the contract, then I can change the variables there. No, you are just inheriting from the code and how the code works, okay? The thing is, people that made a storage contract didn't make it open for modifications. If we try to modify that function, the other function, we are going to get errors because they are not marked as virtual here for us to do that. So we are not going down this path. I'm going to create another contract called my storage from scratch, and I'm not going to inherit it from anything. I'm just creating a new contract so we have freedom for changing things, okay? And we are going to do exactly as you suggested. We are going to put some code in it, but everything else we are going to copy from the previous one. So we don't need to code that again. Even though it would be a good exercise, we don't need to waste time here. I'm going to copy everything from line 11 to 28. Pasted code alert. This is a very good alert, okay? Do not dismiss that without reading, like I did. And we are going to remove the comments. That alert is important if you are using like your mainnet account that has money on it. It prevents you from being scammed by other people, okay? In this situation, we are just copying some harmless code inside the test environment, so there is no harm. Okay. I'm going too fast. Catching up. So now we have exactly like the storage, we have a state variable number, a function store, and a function retrieve. If we compile and deploy, we are going to see that we have the same behavior. We have the number 0 as the initial value. If we store anything, it is going to persist there, okay, for future calls. I'm going to show you a way to change the initial value of that number. When we call that contract, the number always starts with 0. Okay? There is no garbage inside the EVM. Every time you run a function, it gets a completely new instance of the EVM to run it. So it is going to check what is the number. The number, it is in a contract that was just deployed. It is going to be 0. There is nothing stored there. 0, 0, 0, 0, 0, 0, 0 bytes. Okay? That translates for 0. I want to make a function to be run when I deploy, like function initialize, something like this. But if I make a function like this, it is not going to trigger automatically. I would need to call it again. For example, I want to make the number equal to 1, 2, 3 when I deploy. If I make this with a function, like the function store, let me clear that up. Retrieve, it's still 0. I need to initialize first, and then I can retrieve that value. That's not what I'm trying to do. I'm trying to make it run when I deploy. So for that, we have a language feature. That is the constructor function. This, let me fix one thing real quick. Okay, much better. Let's keep the bugs away. the constructor is an optional function that is executed upon the contract creation. It is part of the deploy transaction. It is not even part of the runtime code of the contract. It is something coded inside the contract. I'm going to code this constructor function here. Okay. It is going to be inside the solidity file. But it's not going to be stored on chain as a runtime code. I can't call it later. It is a piece of code that is going to be executed by my wallet when I'm deploying that contract to set some initial variables, set some initial conditions. Okay? And the same way that when I'm calling store, I can pass a parameter to it, this same way, when doing this constructor function, I can do it like this. I can pass a parameter called initial value. Okay. Now when deploying the contract, I can't just click deploy. A while ago I just clicked deploy and it works. Now it doesn't work anymore because I need to pass an initial number. For example, I want to be 123. Now that I have this parameter, I can transact and it's going to deploy a my storage contract. Now if I click on retrieve, I have 123 as the initial value. Okay. This piece of code, this transaction, this computation is only computed at the deploy transaction. If I try to call constructor again, it is not possible. I can change it, for example, to another number, 500. It is 500 now. If I try to change back to 123 with the constructor function, there is no way to call it. Even if I deploy again, let me deploy again. Now I have another contract with 123. I did not trigger the constructor function for the previous contract. The previous contract is still reads 500. Different instances. Okay.
But where is the initial number?
The initial number, this? It was it 123. Yeah, I put here 123 under the deploy. I'll give you some time to catch up. It's important that you understand what's going on. Questions in the meantime?
We use the fake money for the fake net. Who's maintaining the service?
This is a good question.
Arbitrum?
Another person asked that. So all of those test nets, they emulate the functioning of a mainnet as well. But the miners are not compensated for that financially because they are receiving fake money, fake payment that they can't use for paying electrical bills and such. So it's like a pro bono work. People are doing that for the goodwill of the ecosystem, you see?
So it's still people? It's not Arbitrum, it's not...
There's people from Arbitrum, people from Ethereum Foundation, from Consensus, common people like us. They support the ecosystem. And this is why the testnet's performance is bad. It's heavy, throttled, low latency, because people are doing that pro bono, you see. Okay. So there is a whole explanation about constructor function here in this article. For everything that we are going to see this week. Hey people, you still need more time?
Yeah.
Okay, good.
Lo stesso codice?
Okay. So the idea here, people, is we are going to see a lot of concepts like this. For all of those, we are going to have a documentation to back it up. Okay. Hey people, just a quick. They're having problems there. So we are going to have a lot of concepts like this to go over in this bootcamp, and I'm going to leave the links there for you to explore later. There are good theoretical things to be aware of, but it's not crucial for this weekend. Okay, so it's like a shortcut. I'm going to be showing a lot of information, but it's always good to check them in the documentation later. Okay, at your own pace, at your own curiosity. So this was constructor function. Okay, different from all of those other functions, they do not set an entry point for you to call into the contract. They are more part of the deployment transaction than they are of the contract itself, the contract running code. The other functions, all other functions, they are part of the contract code, so you can invoke them somehow. To invoke a function, it can be either public or external. I quickly mentioned that yesterday. The options are here into the grammar. When you go for function definition, you have the visibility options that are internal, external, private, public. Only external and public allow for external calls. Okay? An external call is an execution that is not inside that contract, could be another smart contract or an EOA, an external on account, calling that from outside. Okay? And there is no access control here. There is no check. Who is calling? Doesn't matter. We could implement a check here. In fact, we're going to do it today. But in the baseline, our function does not check who is calling. Okay? Yes?
So what's the difference between public and external?
I'm going to demonstrate that now. At the first, I'm going to demonstrate that public and external can be called from the outside. First of all here, store and retrieve, they are all public, you see? So they can be called from the outside. If I mark one of those, for example, as internal, I can do that, the contract compiles. Okay? And if I deploy that again, then I don't have an entry point for that anymore. Even if we send a transaction there with those same bytes, AB, 1, 2, 3, 4, CD, remember those bytes? Even if we send the same transaction, the contract now is protected, is safe from executing that. The only possible way to call it now, it is internally. For example, I could do that. It works. An internal function allows me to do that. Let me deploy that for you to see. See? It worked. The constructor called a store that is internal, and it worked here. But now I can't call it anymore. A public function allows for both. If I make a public function, now it can work internally from the constructor, but it also can be called from the outside, from an EOA, you see? So it allows both internal and external access. Okay. What do you think that's going to happen if I put external here? Only from the outside. So the line 9 doesn't work anymore. Okay? It is saying like this, like that meme. I never saw that meme in my life. It's just here in line 12, but it can't see it. Because for the contract, it is as if a store function doesn't exist.
If I don't put the visibility, what's the default one?
There is no default one. You need to put.
Ah, okay.
Okay. There is no default. By design. Okay. So, yes?
So what's the difference between private and internal?
Let's get exactly that. Externals only allow from the outside. Public allow from outside and inside. Internal only allow from the inside. So private. Follow the logic. Imagine a quadrant. So external, internal. The public allows both. Here. External only allow from the outside. Internal only allow from the inside. So private?
No one.
That's the logical conclusion. And it's wrong. Sorry. Because I saw some people confusing that in the past. So private is not the fourth quadrant. The fourth quadrant, it wouldn't make sense. You have a variable that you cannot access, so why did you put that in the code to begin with? So it doesn't make sense. To do a private function or state variable, it is the same thing as an internal. Okay? There is just a small difference. A private is protected when you are compiling the code. It has nothing to do with the blockchain. When you are compiling the code, a private variable is protected so that inheriting contracts cannot access it. Just at compilation time. You could inherit it from another contract, but still you cannot access it. Only the mother contract have access to it, can access that place in the memory. Okay? At compilation time.
So if you name the function, you can use it if it's internal.
Like my inherited storage is storage. It's my storage. Okay? If I try to read here store, it is private, it's not going to allow. But if I put like internal, then it works. Like this. Let me cut this. Yeah. Look, this works. Let me deploy my inherited storage with the number 123. So now I have retrieve 123. It works. But if I put here private, now this doesn't work. It's just at compilation time. When compiling an inherited thing. So it's a very technical difference that's not so important. So for today, you can understand private and internal as doing the same for us. Okay? They do not allow external calls. Okay? For today, that is good. So to recapitulate, public allows anything. External only allows from the outside. Internal and private does not allow. They do not allow external calls.
But what if like my function store returns something? Like I just like try to return like I don't know why. I mean, where you into the 256, and it is giving me a warning.
Yeah, because whenever you return something, you need to specify it into the function declaration as well.
Yeah, exactly. Yeah, but what is it happening? Like I can see the transition on like Ethernet.
Yeah, for example, let's make it public and return a number, and it returns number like this. Yeah, I can. So when I deploy, let me just check one thing here. Don't need that. So when I call it to store something, it is going to give an output here to that transaction. Here, a decoded output of number 1. You see that? The transaction. If I don't put that, and if I call that again, I don't have that decoded output anymore. It is just the input. You see, the decoded output is empty. Okay, small detail. So questions about visibility?
To call a function from another contract, instead this need to be public or external?
Public and external. The only thing that is calling from inside is code that is in the same contract. Okay?
Oh.
My storage calling itself. Okay?
So another contract is considered internal?
External, another contract. If I have, my other contract, I can call it. It's called an external call. But the function needs to be public or external for it to work. Okay? A good question that sometimes arises is like, it is possible to call an external function from inside doing an external call? It is. For example, I could do this dot retrieve plus number. And surprisingly enough, it works. It is a contract doing an external call to itself. It is quite weird, but it's also good to consolidate how external calls. This contract, when doing this call, it is leaving itself, going from the outside, returning, knocking. Hey, someone is home. Yes, I want to know the retrieve function. It's 42. Okay, thank you. So it leaves again and returns and continue the computation. That is possible.
Why should I do that?
Don't know. It's possible. It is sometimes like a pattern for you to follow in some contracts, but it's a very edge case. It's just good because this can do some confusion, and also this consolidates how external calls work, because if I deploy that now, let me, what happened? Is wrong. Okay. Here. It's behaving weirdly here, but let me try and deploy that now. Yeah, it's not allowing me. It's not giving an error either. Okay, I demonstrated that for a lot of times already. So, external retrieve needs to be done like that. If I make it public, it doesn't have that problem anymore. I can just call retrieve directly and it would work. Okay. Good. So if I deploy that, and if I call like store plus 1, it's going to retrieve 1, 2, 4. Okay. Let's undo some of the changes here. Okay. Number, store initial number, only possible because we have it public. Now to the second part. This takes a while. It's normal. Visibility. Now we have state mutability. How many options? Give a read here. How many options do we have for state mutability? Are you sure? Three or four? It's clear. The answer is super clear, right? How to mistake, right? It's 4. The default mutability non-payable, 1. Pure, view, and payable, 1, 2, 3, 4. Okay, 4. It is not clear. Yes, I get this complaint sometimes. The documentation is not clear, but we have 4 options for state mutability. The thing is, one of them is default. Visibility, we don't have a default value. For state mutability, we have non-payable. Okay, but the confusion don't stop there because you pay for non-payable functions, but you pay for the call, not for the function itself. Okay, that's not my mess. I'm going to undo this. This is confusing, I know, but I'm going to guide you through each of those steps. There are 2 things: paying for the transaction and paying for the function. You can see the difference. It's like going for an amusement park. You can pay the entry fee, like to enter the park, I pay 10 euros. Okay. So, okay, I'm in. Now that I paid, I can do free things, like walk in the park, sit on a bench, talk to people, get a duck. In some places the duck are for free, you can take them. Not in all places, don't know in Italy, okay? Don't arrest me. Or you can do a pay thing, like you can ride in a roller coaster ride, that you need to pay another $20, 20 euros. Or, you see what I'm getting. You want to enter the circus. You already paid for the entry of the park, but you still need to pay for the other amusement, okay? So one thing is paying to enter the park, the other thing is to paying to access to things inside the park. The same thing happens to those transactions calling functions, okay? The first one and easiest one is the pure, this option, pure. That is when you don't pay for the transaction and you don't pay for the function and you don't care about the state of the blockchain. Okay? A pure function is like returning a constant, like function initial number that it is public. I'm going to put it as pure, and I'm going to say that it returns a uint 256, a number, for all that is important now, and I'm going to say that it returns 42. And instead of having this initial number here in the constructor, I store the value of the initial number pure function. It is like a constant. Okay? It cannot read the information from the blockchain. For example, I cannot say that initial number is number plus 42. No. When it's pure, it is totally ignorant, it's totally blind to what is happening into the blockchain. So, when we try to pick number here inside a pure function, it is saying, hey, this function is declared as pure, but this expression potentially reads from the environment. And then it requires view. View is another state mutability that is free to call. It is, the function is free, the call is free, the transaction is free. It doesn't get included in the blockchain as well, but is able to access the state of the blockchain. Like we have the retrieve function. That is view. If we put the retrieve function as pure, it breaks because it needs to access the state of the blockchain. If we make this initial function, initial number, view, this initial number function gets a warning. Hey, it is marking as view, but it doesn't need to access the environment at all. We can restrict it to pure. Okay? So those two walk side and side as free functions. One of them can access the state of the blockchain, the other cannot. Okay, yes.
When I try to store more than one number, like I created two variables, like number and number 2, and when I store two numbers, it's like two different contracts.
Inside the same contract? Yeah, those are two different state variables. They are inside the same contract, the same place in the database. Like.
But when I retrieve them, like I retrieve both of them?
You can retrieve separately, or you could retrieve both of them. See? Like, imagine a token. You have the balance of a lot of people, a huge amount of people. You can retrieve each one separately. Okay. Visibility, pure and view. They are free to call. The function is free as well. One of them can access the state of the blockchain to answer for things that are happening there, the balance of someone, block number or whatever. The pure function cannot. The pure function only returns constant expressions or constant things. Okay? You can make a pure function to do some calculation based on the inputs. For example, a pure function multiply AB. So you pass A and B, and it's going to return the multiplication of those two. This is also a pure function. Okay? Questions so far? Now the next one. That is the store function. What is the mutability of that store function? Non-payable. But when we call it, it's free. When we call it, it is free.
You pay for the access to the fund.
Yeah, you pay for the transaction, you see. So it's called non-payable, but you pay. But you don't pay for the function, you pay for the transaction. Okay? It is confusing, but they chose that name because you don't pay for the function. Okay? You pay like a normal transaction, like any other transaction you do into the chain, for sending money, for doing whatever, deploying a contract. This is a contract that you pay for the transaction, but you don't pay for the function itself. Okay? This is the visibility of non-payable. You don't pay for the function. Okay? Question? The only thing that left for us is payable. The payable function, the only difference is that when we deploy, now it becomes red. But it's do the same thing. Weird, isn't it? Hey people, give me just a minute for that. The payable function could be called the same way as the non-payable function. So it changed the number that it's here. I'm going to change it for 999 now, and it's going to work. So a payable function is not a function that you necessarily need to pay for this. Okay? A payable function is a function that is able to receive a payment to the function, to the contract, not to the transaction. When sending this store function, let's say for 1,000, I'm going to send here into this value box, I'm going to send some money together with that function call. 1 ether, put here. And I'm going to call it here, this store function. Now it changed the retrieve for 1,000. But now the balance of that contract is now 1 ETH. I have 1 ETH stored in that smart contract. The program has money. Not the owner of the program, not the company that created the program, not the developer that deployed the program. The program has money. Yes, your buggy software now has more money than you. That strikes you, but it happens sometimes. The smart contract is holding money through the payable function. If you try to do that with a non-payable function, let me deploy it again. And now I'm going to try to send 1 ether to the store function, to store 1, 2, 3, 4, 5. We have this problem here now. The transaction failed. Transaction has been reverted because you called the function with money, so it should be payable. You try to throw money in the face of the contract say, no, I do not accept money. This function you're calling is not payable. We don't do this here.
Why do you want functions of program that takes money?
For example, to do some mechanics here, some clever mechanics. For example, whomever pays the more can put the number here. Or the number is exactly the amount you pay. Okay? Or to put a number above 100, you need to pay. Okay? Imagine this was a text. You want to put your name here, you need to pay more than the previous person. And the money goes for the previous person, for example. So you put your name there for $100, the next guy tried to put a name for $200, you profited 100, see? So you can do money mechanics on inside your code. Okay? You can make like require a payment to do a casino, online casino, or a game that you need to pay for playing that game. Buying tickets from things, posting a bet in an on-chain auction, all of those kind of things could use payments. And this is the way to make a function accept payments, okay? Remember this well, it only works for ETH, the native tokens. Ethereum, ETH in Ethereum. It doesn't work for other tokens, okay? Other tokens, it's a different process. This payable only works for ETH, for Ethereum. Okay.
Question?
So
what if I want to do it like with an if? If you okay.
We are going to cover this in the next one, that is the units and global variables. That you can pick, for example, the message value. Here, message value. To make an if statement. If the payment is that, I do this. If the payment is not, I do that. I revert. That is possible.
I don't know if you just responding, but I mean, like, if, for example, the number it puts, the value you want to store is like more than 100, you need to pay.
Yeah.
Okay, you can do it like.
But for it, the function needs to be payable. Even if some situations it's going to run for free, because in one situation it is payable, all of the calls should be through the payable.
Yes, but it doesn't throw an error if if the user doesn't put in the money.
No, it can be sent with zero money, for example. Okay. It works. Okay. Because the user is always paying for a transaction, for a state changing transaction. But usually it only pays for gas. So the value is always higher than zero, but the byte of the smart contract is zero. If you put payable, you say, hey, now we are going to split with me. Some money is going to come here for the contract, the other is going to be paid the miner. Okay. You had a question as well?
So that could be the base from an exchange.
Yeah. Remember when we swapped ETH for rapid ETH? We were calling a payable function.
So taxes are based on this kind of functions?
For native tokens. For tokens that are not native, the process is a little different. Okay? At least in Ethereum compatible chains. Okay? For payable functions, the only thing that is accepted is ETH, Ethereum based token. Okay. Questions? Questions? You have questions?
This pure function was for the
Okay, let's review that. It's easy to get lost. So pure can be called from outside or inside, doesn't matter, but it doesn't have access to the state of the blockchain. Okay, it's going to answer the same thing no matter what. View has access. Non-payable and payable, they change the state of the blockchain. Payable may receive payment. Non-payable is not able to receive payment. Okay. Let's do the last push before the break. A last exercise here. A lot of chats. They're chatting about interesting things. Should I interrupt you, or are you chatting about cool things, or I don't know? You all sound too excited. Yeah, question?
You need to specify pure every time you have some calculation without looking for the state of the...
For functions, yeah. Whenever you create a function, pick the remix. Whenever you create a function, you need to specify a visibility, and if you don't specify the state mutability, it's going to be non-payable. Okay? Yeah. If you put pure, it means that it's not going to cost money for calling. It's going to return for free, and it can't access the state of the blockchain. Okay?
Yeah, but we have a function like a sum or an average between two numbers. We must put pure, or
you can put like view. If we put, for example, view in a function that would be pure, it gives a warning. It's not an error, but it's a warning. The compiling is saying, hey, you are creating a whole set of operations to access the state of the blockchain, like connection to the database, such like, without need. Okay? And it is important to optimize. This is good for everyone. Hey people, a very important information. It is important to optimize things that you put inside pure and view functions. Okay, don't do too much computation without need. Because even though they are free to call directly, when you are calling a function directly, só minutinho. When you are calling a function directly, you don't pay for the pure and view. But when it's calling from another function, let's say store calls retrieve, that calls initial number, that go back and go back. Everything you do down here is going to be billed. It's going to be paid when calling store. So if you have a pure function that is huge, it's doing a loop, a giant loop, when you call it directly, it's for free. But if you call it from another function, that is a state changing function, like payable or non-payable, and it calls that pure function, do a huge loop and return, it's all going to be paid. It's all going to be computed in the cost of that transaction altogether. So you pay for all, it's called gas, yes, but you pay for all the computation that is involved. It's not because it's inside a pure block that it's going to be free forever. It is free just when you call directly. Okay? So it's important.
So you create the function that you need to do the loop, like you said, And when you call it from a payable, non-payable function, it depends on where you call it.
Yeah.
If it's paying or not.
And yeah, depends where the entry point is.
So you create the one that you're saying is not payable, so not specified, and then you call it where you want to.
For example, if I call from store here, if I call initial number plus number, then all of this gas, this 359 gas here from this function is going to be added to this function. Okay. Yeah, because it possibly would overflow. So this function usually costs 22,000. It's going to cost 22,800 instead of 22,500 if you do it that way. Okay. Good. So last mile before the break, I'm going to show you these public units and variables, because sometimes you need data that is in the blockchain. For example, I want my initial number to be the block number. When I'm deploying that smart contract, I want to store, instead of initial number, I want to deploy the block number, okay, with the initial value as block number. So one way to do that is to receive block number as the parameter. Okay, and then I store this. Okay, mic is coming off. Don't know if okay, return. So this is one way to do that. When deploying, okay, yeah. When deploying, I can look for the block number into the Explorer and pass it as a parameter. That is possible. Let me deploy this block number. I'm going to look into the blockchain, what it is in the Explorer. Let's say Etherscan. I'm going to look what was the last block number. The block number is this, and then I pass for remix. Okay, that is one way to do it. When I want the initial number to be equal to the block number, so I could pass it by parameter, and then I look on Etherscan what is the block number, and then I pass it here. Okay, but there is a problem here. I could lie. I could bypass, I could cheat, I could put another number. You're trusting the user to pass the correct information. To remove this burden of truth to the user, you could use the state of the blockchain itself by picking this, where it is, here, this MSG object. You don't need to declare it, it is available for you. MSG, it is there. Block number. The MSG, no, sorry. Yeah, the block dot number. I was looking the wrong place. MSG is for the next step.
Even more cheating.
The block dot number. Yeah, sorry?
Even more cheating. Message dot block number.
Yeah, I see what you are getting. So when I pick the information from the block itself, it is impossible to cheat. Okay? And also, when I'm sending a transaction, I don't know in what block it is going to be included. Could be the next one, could be 2 blocks from now, 5 blocks from now. So my best guess would be an estimation. Here, no, I'm going to have exactly the block that it was included. So let me do this deploy. And here we have the initial number as 10. Because we are in the 10th block of that test network, on that virtual machine network. Let me do 3 transactions here. 1, 2, 3. And then I'm going to do another transaction for deploy. What do you think that is going to be the block number?
11.
It's discover. 14. It was 10, I did 3 transactions plus the deploy transaction. So, yeah, I know. I'm using a virtual machine blockchain.
So
every block carries 1 transaction. Yes. If it was a public blockchain, it would be the block that the transaction lands in. Okay. This only happens into the virtual machine blockchain. Okay. And now a quick exercise, 5 minutes or 10 minutes. I want to implement an ownable behavior in that smart contract. Okay? I want to restrict the store number so that only the address of the deployer may call it. I want to make any other call to revert. So a starting point is this. This function is store. Okay. And I have a boolean to determine if the owner is calling or not. I've hard-coded it to false. And there is a to-do here, a small exercise to check if the owner is calling that function or not. Okay? You are going to find the MSG sender variable here that returns the address of whomever is calling. Okay? So you can include it here to check if the MSG sender is the owner or not, for example. So if I don't have the owner calling, I'm making that revert statement. What is that? The link is here. The control flow structure. That you have if, you have while, you have for, you have all of those inside Solidity. And also you have those error handlings. That are where it is. Error handling here. That they stop the execution of the function, like throwing in an error. You throw, like in other languages. It stops the execution, okay? It breaks, but it is a little more special because if you have a lot of instructions inside the function, give $10 to Josh, charge $5 from Limone, transfer $1 from my account to your account. You have all of those instructions. And then you have a revert. It's not going to leave things as they are. Okay? It's going to roll back all the changes.
Inside that function?
It's inside that function that reverted. It's actually inside the whole call that reverted. It's possible to try and catch, but forget that for now. So this is what the revert is going to do. That is possible to assert and require, that is the opposite. For example, I require owner is calling. It is doing the same thing, okay? I require that the owner is calling. If not, the owner is calling, revert. Okay? 2 different ways to write the same thing, okay? And there is another variation that is assert. That is just required with more drama. Okay? When you want to dramatically fail with a panic, you assert. Okay? Require are for things that are expected to go wrong. Assert is for things that you never expect to happen. Okay? For example, I'm leaving my house and it is raining. So I require not to be raining to go out. If it's raining, I stop and go take an umbrella. Okay? It is so uncommon to be raining. I don't know here, but in Brazil it rains almost every day. You are not going to panic out because it's raining, right? Okay? But when you leave your house, you can assert that it's not flying. Because if your house is flying, if you go out and there is no ground, then you can panic. Okay? Your house is flying with some balloons. This is the difference between assert and require. Require are for things that are okay to fail. Your client is calling your function without money. Okay, so you revert normally. Assert is when something breaks. And then you can assert for constant, you can assert for certain conditions that should never break. When they break, you throw a panic, okay, a special kind of error. Okay? All of that just to explain that there is revert, require, and assert to do quite the same thing, with different shades of drama. And Boolean is owner is calling, if not owner is calling a revert, or require owner is calling. How to determine if owner is calling? I could check if msg.sender equal to my address. What is my address? This. Beautiful implementation, isn't it? There are much better ways to do that. I know. So this is why I put the to-do. It works though. But I have a to-do here, and now it's your little exercise. As soon as you complete that, you are free to take a break and have a lunch. Okay? Have a snack. Okay, questions? This is the code you should copy. Those are the links. And you should restrict this function so that only the owner can call. Okay, just to explain one thing. This smart contract here was open. Anyone could call it and change the number, right? The version that we are doing now, this version here with this ownable, has a logic to restrict it. A logic to allow some people to do the transaction, other people not. Okay? It's something that you can code inside the smart contract. Alrighty? We see. Owner, private, good. Good. Owner, yeah. So that's good. How to programmatically set the owner as the person that deployed the contract? Where in the variables that is the contract deployer? Let's see. Contract deployer, contract deployer. There is no variable like that. How to get the contract deployed? There is a clever way to do that. Good. It is not that difficult, but you need to think a little. What is a function that I can get the deployer of that contract? Think on that. Very good. Owner is calling. I can check if the msg.sender equals to
owner.
What?
Yeah, that's
And how to get that?
on the constructor.
But how to make sure that the constructor function is being called by the owner?
Because the owner deployed, so it's sure.
Isn't it possible for other person to call the construction function?
No.
That's it. Good. It's important to be convicted. Okay. At some point, you get certainty of what you are doing. I'm sure the construction function cannot be called from another person. Okay. So you get confidence on it. Okay. I know that this is the second day of lesson. There are a lot of things that we don't know, and it's important that in your head you can separate what you still don't know, what you still is not sure, but you should have conviction of the things that you already learned. Okay, so you slowly try to build on that. It's important because sometimes you have conviction of the things that you don't know yet. Okay, the Brandis-Ney's law, something like this. And it's important to deal with that in your mind, in your learning process. So for example, I know that the constructor function cannot be called from another address. So I can create a variable, a state variable of the type address, that is this type, okay? Call it owner, and then make owner equal to MSG sender at constructor. MSG sender at the constructor is going to be me or whomever deploys that in the future. So I need to check if the MSG sender equals to the owner. Then I completed this to do here. Okay. So I can require owner is calling. And if that is false, I can even revert with a message by doing like this. The second parameter of a require is the reversion message. For example, owner is not, the color is not the owner actually. Like this. So if I call that, let me store the number 10, 12. It's now 12, okay? Now I'm going to pick another account. I can select accounts in that drop down. I have lots of pre-funded accounts. So I'm going to select the second one and try to store another number, like 15. Okay, you see what's happening. I did not deploy again. Let me deploy. Then if I try to record something with another account, it fails with this message. Color is not the owner. Okay. So this is what require you. It's the same thing as revert, but require you can do this structure. You can make like color is not the owner here. Okay.
Where the message will be visualized? Color is not the owner.
When you have a reversion, when it reverts, and then the contract can say the reversion error is this. Color is not the owner. Okay? It is good to put a message because sometimes you have a chain of a lot of contracts calling one the other. It's not that easy to determine why it has reverted. So when you put a reversion message, a statement, it reverted because of that. It can make your life easier later on if you want to fix that problem. Okay.
A quick recap: require versus assert versus revert. So require is basically a revert plus the if.
Yeah, require is just the complementary for the revert. Okay. Like if you go out and it is raining, go back and pick an umbrella. The same statement is pick one umbrella if it is raining. You see that they say the same thing in different orders. And assert, you throw at random. You panic. It's raining. I'm made of sugar. I'm a snowman.
But it reverts the transaction.
Reverse as well. They all revert. And last but not least, there is a simple structure. It doesn't go on chain. It's more about the compiler that you can put those checks inside function modifiers. Okay, it's just a language feature. So instead of doing this require owner is calling all the time, you can make something that is a modifier. Modifier, like this. And you give it a name, like only owner. And then you can append or prepend it in any function. It is not going to be uploaded to the blockchain. It is just in the compiler, when you are compiling the smart contract. So you can move those two lines there. Like this. The modifier is doing the same operation, is doing a require if MSE sender equals to the owner. Okay. The only difference from a normal function is that you need to put this symbol, underscore, semicolon. If you put this before, the modifier is going to be executed at the end. If you put this after, the modifier is going to be executed before. And you could even do a sandwich, like do something before, go for the function, and do something after. That's possible, okay? That is a modifier doing something line 10 before, line 11, it jumps to the function it is modifying, returns, go for line 12. It's very similar to a go-to, if you ever use the language that he uses go-to. So for example, this function store, I can make it only owner, like this. I can mark any function in my contract only owner to make them execute that modifier before. Okay. When this is compiled, the bytecode is the same. The bytecode we had before making this modifier is the same bytecode after making this modifier. What the compiler is going to do is copy those bytes of code and pasting in the correct space, you see? Bytecodes are the same. What is changing here is that your code is a little more organized now. This only owner can be reused later on, okay? And making it return after or making it return before can have big differences, okay? Depending on what you're doing. Good? Questions? Yes?
How is it called, the separator and the modifier? The before and after?
This underscore?
Yeah.
So it's just the exit statement, okay? That executes it is a special character that is only using for the modifier, and it executes the rest of the code, okay? You can put it after, or you can put it before, or in the middle.
So, tell me if I'm wrong. Everything before is going to be executed before the function actually obeys the instructions, and everything after all the instructions in the function has been executed, it gets executed.
Yeah, for example, if I do that, owner equals to address 0. For example, when I do this, and for example, let me deploy. For example, I'm going to retrieve, we have 0. I'm going to store like 42. It works. Now it reads 42. Who's the owner now?
0.
So if I try to restore 99, it doesn't work because I've set owner to 0. Okay, so it means that after the owner has used one function, it has burned. Okay, it has stopped working. You can do things before and after.
So the modifier could just start with that special character.
Yes, so you would do everything after. Okay. Good.
Can we restrict also the color of the constructor?
Modify the constructor, no, because you can make it work. It's just not what it was intended to do, okay, because it should modify functions inside the contract itself. Let's try this here. Okay, so it works. It's not going to let me deploy because, see? But what if I do this? And now, what do you think? Now it deploys, because it's doing this first and then it's doing that. Okay. So you can apply to the constructor, it's just not what it was intended to do. Okay. Questions? Thinking? Yes.
But this underscore is only for one line of code or for
the entire function?
The entire function. Yeah, you are modifying.
The entire function.
Yeah.
Okay.
What's going to happen is that the line 10 is going to be copied before line 18 every time you call it. Okay? The compiler, for the compiler, the modifier doesn't exist. It just copy the code back and forth. It's more a language feature. Okay? About the require statement, about the ownable, about the function calls, state variables. How many types of variables we saw today?
Others.
And? Boolean. Yeah. So, did we need to explain each of those types? So you see that of course the theory is very important, you should look at the theory later, but eventually you get acquainted with the things you're using by practical experimentation. Okay? And the good IDE, the errors that happens and all of that, guide you the way. At some point, my intention is that you don't even need a teacher anymore. You can by yourself teach all that Solidity has to offer. Not because I don't want to, I would love to. It's just that the things are going to change so fast that for you to be a Web3 dev, you are going to be a forever student. People are going to launch zero knowledge stuff. People are going to launch all the networks, layer 2, layer 3, layer 4, layer 42. They are going to launch a lot of things, and you are going to keep studying by yourself. If you wait for a teacher to be instructed on that and then teach you, then you are going to wait 6 months for something that you could be using. So through this bootcamp, through all of my bootcamps, I try to foster that you have tools to guide you, tools that show you the path, so that you can explore building those smart contracts, building the D apps by yourself. Okay? Of course, whenever possible with the help of a teacher, but eventually you're going to need to pick the pace of guiding yourself through Solidity and through blockchain and all. Okay? This is why my next topic is ditching Remix. You can use Remix for building production level things. You can use Remix to deploy your contracts, to test your contracts, to run scripts. You can even use it to debug and do more complex actions. But there are some dev toolings like Foundry and Hardhat that are almost standards for all the big projects to develop secure code, develop code that you can share with all the team members, that you can check execution, that you can properly manage version control, that you can later on integrate in a front end, integrate easily in a back end, okay, that is reusable. Remix is great for many of the things, but it falls short to many of the capabilities of those dev toolings. Okay? So we are going to stop using Remix for this bootcamp. You can still use the hackathon if you want. You can still use to study if you want. But we are going to start installing some dev tooling in our computer, okay, in our device. It's not going to be only browser-based. And to have a better glance of what those tools are going to do for us, I'm going to pick this repository as an example, Open Zeppelin Contracts. We are not going to use it now. It's going to be useful for us. It is a library for building smart contracts, like little building blocks, like Legos, that you can use for building smart contracts. It is useful. We are going to use it. But for today, it is just an example. Okay? It is just a showcase. We're not going to use the thing itself. It's like a role model for us. Because if those guys are making it, it's one of the most secure and community vetted libraries that there are in blockchain develop, if not the most secure at all. If they are doing that with 426 contributors, used by 21.3 thousand of people, running billions of dollars of things, if they are doing it and they are working, if you use the same tools and techniques, probably you are going to work well as well. So we are not going to be discussing here, hey, this tool is better, oh, that tool is better, I prefer Foundry, I prefer to write my tests in Solidity and all of that. All of those discussions are good, they have value. It's just that for a 1 week boot camp where we have this showcase, for example, we can shortcut here. So later on we can discuss that more property. But for example, we are going to clone this repository. We are going to see in the package.json that when you run the compile the script, it uses that tool called hardhat. So hardhat it is. We're going to keep using hardhat for this bootcamp. Yes, question?
Using like hardhat or even OpenZeppelin is a sort of validation of your project. It's like you use that, it should be secure.
It's using the right tools. Okay, I would say the opposite. If you don't use those tools, it is a kind of a yellow or red flag for your project. Okay, the same way that, for example, a construction worker using a hammer is not a guarantee that he's good. But if you see a construction worker using a sausage, yeah, or the guy is the greatest construction worker in the world, or he doesn't know what he's doing. Okay, depending on the frozen sausage, it could work for nailing things down. But you get what I'm saying. Using the tool does not guarantee that you are doing a good job, but not using the tool can be a heavy indication. Okay. So for this to work, you are going to need this program called Git, okay, to clone things and download in your computer. Depending on your environment, things could behave totally differently. If those tools doesn't work, for example, you can download and clone this as zip, for example, and extract in your computer. But the normal ways to develop things are like this. You are going to pick an empty folder set aside in a device. For example, I'm going to pick here my desktop that is empty. Where to pick a location on a computer? Like, don't pick it inside another project. Don't mix it inside another project. Don't pick it inside somewhere you did initialization of a repository. Look for a safe place, like an external driver or a place that you can put the things on your computer. Okay? For example, desktop. And I'm going to create a folder here. Create new folder, like project. Okay. So it's empty. Create a new folder in your computer in a place that you know that is safe, that you're going to find it later. And then we are going to open a terminal here. For me, using Linux, using Arc here, Manjaro, I just right-click and open terminal here. If you are in Windows, you could open like PowerShell, Shift, right-click and open PowerShell here. If you are in Mac, I guess you can do, I don't remember, I don't speak millionaire, but what is the command in Mac? There is a command to open the terminal at the folder you are at. So just command?
Yeah.
It's command something, no?
It's like command space.
Command space, yeah. Or command. No, you see, they never had a Mac, I don't want to. So open a terminal in that folder. If you don't know how to open that folder, you can open just a terminal and then navigate like CD, change directory and go for that folder, that safe folder in your computer, okay? In Windows, avoid using CMD. Using like PowerShell or Windows Terminal, okay, it works better. Linux, you can use any kind of bash or shell or terminal you would like to, okay? In Chromebook, does someone use Chromebook here? Okay, no, thanks a lot. Because it creates so many problems. So you're going to open a terminal in that folder, and then you are going to do this command, git clone, that is going to use a git binary that you have in your computer or just installed in that link to download the whole the whole files from that repository. It's the same thing as downloading the zip and extracting to that folder. Okay? When you do through Git, you can more easily sync up your changes with the project. Okay? But we are not intending to change anything in the project, so if you download by zip, it's okay as well. It's normal to take a few seconds. After you complete, you should change directory and start entering Open Zeppelin. But at this point, if you are not very familiar with using the terminal, with using the command lines, you could get lost really quickly, or you could like do typos and all. A very good suggestion is everything that you would type in things, be lazy. Hit tab and it autocompletes. So you don't have the problem of committing a typo, of missing your repository. And if you hit tab, it does not autocomplete, it means something's wrong. You didn't clone the repository correctly. So you start typing the word and hit tab. It saves you from a lot of problems. Okay? To check if you have done correctly, it's not needed, but just to check, you could do like ls, or something like in your terminal or in your shell or bash, to list the files that are there. So indeed, we have downloaded all the files that we need. Okay. The second thing we are going to do is using vi to open package.json. Oh no, I don't know how to quit. Someone help me. How to quit? Ask is not working. I'm stuck forever. So we are not going to use vi because of that. A lot of people have been stuck there and they have to reset the computer. So for that, I suggest using the VS Code. Or if you have all the editors, could work as well. Notepad, a lot of people program in Notepad. But VS Code is great. If you want to use Vim or Nano to code as well, be my guest. I'm going to open VS Code here by doing code and dot. That dot is very important. Is the folder I'm at. So this is going to open VS Code here for me. Okay. If code dot doesn't work in your shell or bash or whatever, you can open VS Code normally and navigate to that folder. Like open folder project, it works as well. Okay. You don't need to trust the authors if you don't want, but in this situation I know the project, I know the comments, I can click on trust. And now I have here open in the file explorer. It's similar to Remix. Actually, Remix is similar to VS Code. We are going to see all the files in our projects. Not only the contracts, but all the files. Okay. Let me just get rid of that blue badge here. Okay, done. Those are the files that I have downloaded. So one of the files that I was showing you is this package.json. This is a JavaScript project, a project that uses a lot of JavaScript. It is intended to be run with interpreters, engines like Node or even Bun. And JavaScript files, they are not executable. Okay? You can execute JavaScript files when you run them through an engine like Node, Bun, or whatever. For it to work, you need to structure your project. The structure of the project is the package.json. Okay? It's different than a C file that you compile, it becomes a binary that you can execute, and the binary guides the program itself. In this situation, the binary here is Node. Node is going to interpret the project and is going to produce output in your terminal, in your file system, in your network adapter, and all of that. Okay? This structure is defined by that JSON. Okay? Who doesn't know what is a JSON? I can explain what's a JSON. A JSON is like a text file, like a CSV, you know a CSV? A comma separate file, with names and values for everything. So it has attributes, for example. The attribute name is OpenZapper and Solidity. The attribute description is that. Okay? So instead of being line 1 is that, line 2 is that, we have key values. Okay? This is the structure of a JSON. JavaScript treats JSONs as objects. Okay? That's sometimes good, sometimes not so good. We're going to use a bit of TypeScript as well, so it organizes this mess. But this could be a file representation of an object. Okay. Good. A kind of document that you would see in a database. But no, it's a file. It's a text file, but it's structured. A JSON. Okay. Good? JSONs? Good? Good. So this is structured like that. We have all of those scripts that the maintainers of that repository prepared for us that we could run. But this project has all of those dependencies. So for example, we need to install this program called Lodash. We need to install this program called Micromatch. We need to install this program called Prettier. Okay? So let's go to the website of all of those and install in our machine, right? But all of those also have dependencies, like 500 dependencies or so. We're going to take a while downloading and installing all of those, right? This is why, for using this kind of projects, for using Node projects and similar, we use package managers. For example, NPM, Node Package Manager, that can install all of those things for this project to run. But instead of installing in your computer, imagine having 10,000 of programs just for that simple exercise in your computer. Imagine you uninstalling all of them later. So instead of installing that on your system, it is going to install some symbolic links inside a folder here. That is only going to be used for that project. If you need to run another project, it's going to install all again. Unfortunately, you have that problem with NPM. It's going to install again and again and again and again in other projects. Okay, you have copied versions of dependencies. But this is also good, because different projects could use different versions, and installing one project doesn't break the other project. So you have that organized by the package managers. So for it to work, I'm going to do npm install, npm I. It works. Actually, a very important step. If you don't have npm in your computer, you need to install Node. If this command doesn't work, you need to install Node. And for it to work properly without any surprises in the future, you need the version 20. Okay? So there are 3 ways to do that. Either you go for the Node website and download from there, or in Windows you can use the Node version manager, or in Linux or Mac, to manually switch Node versions as you wish. Or in Windows you can use this package as well. That is quite a copy and works well in Windows. Okay, so you have the version 20 of Node. When you do that, you are going to be able to execute this npm install command. That is going to install a lot of things on your computer. 943 packages. Okay. Imagine installing all of those programs one by one. Okay. And they all are going to be stored inside a folder here called Node Modules. Look the amount of programs they have here. It's all inside this folder. Okay. I'm going to wait a while for you to complete, but if you want to check if it worked correctly, you can do npm run compile. You can run any of those scripts here. Just pick one. For example, the first one compiled. And then we are going to do node package manager. Please run this script compile. And we are executing this. Okay? If you install it correctly, it is going to work. This command is going to complete. Okay? I'll give you a few minutes for you to install Node, install all the dependencies, and then run compile to see if it works. Question?
Yes, I mean, it is saying to me that like, yeah, sorry, my hardhat it's called. It's not supported like the current version of my Node.js.
So you need to switch for 20.
Switch to 20.
Yeah.
Can I do it like by command in shell or?
I've suggested 3 ways. The best way for doing command by shell is if you use a Node version manager, NVM. It's a program. What operational system you have?
macOS, like Ventura.
Yeah, you have Homebrew.
Yeah.
So you can use Homebrew to install NVM, and then you can use NVM to manage your Node versions.
Okay, yeah, that's right. Thanks.
NVM can install new versions, remove all the ones and all of that. Okay. This is similar to what we were doing with Remix. In Remix, we would run compile, and it would pick all of the smart contracts, the solidity files, and it would produce bytecode. Okay. The thing is that Remix runs in the browser, so we don't need to install anything. Everything is packed in a web application. Here, it is running on computer. It's not running in the browser, so we need to install the dependencies for it to work. Okay, I'll pick a question there and then go back. Yeah.
So the version 20, not the 21.
20, the LTS.
Okay.
20.
Okay. The compilers, right?
If you run yes, that is. Yes. So in my situation here, there is one line missing because I had already downloaded that compiler version. For you, when you run npm compile for the first time, it is going to say downloading the compiler. It's going to take a couple seconds, and then it's going to be like this. Okay. Thanks for pointing it out.
I installed Node, but it's you download it. Download it as a folder. You have to extract and then.
Which one?
How did you do? Let me see.
This.
The binary. But you're using Linux, right?
Yes.
What's your package manager?
It doesn't have, I guess.
By one, yeah.
I guess this is the one for your package manager. It is Ubuntu, right?
Yes.
So I guess you click here in this A. And then you search for Node.
Okay. Nope. Yes, this.
Yes, it has.
Okay.
But let's see what version you are going to install there.
21.
Okay, that's good.
Okay, thank you.
Yeah. Linux, every distro has its own way to complicate our lives. And we love it no matter what. Don't know what's wrong with us. Okay, questions? Good.
É uma biblioteca? O que é?
Node?
Não, esse projeto.
É uma lib.
É uma lib.
Aí você pode usar parte disso para construir seu smart contract, sabe?
Então não é uma coisa que eu consigo, tipo, executar e ver uma tela aqui, não. É uma coisa que eu tenho que usar no projeto.
Building blocks. Como se fosse Lego, para você montar seus contratos. Questions? Have problems? Questions?
No, we're right.
Good? I'm good? Okay. If you are lost in the steps, let me recapitulate here. So, first step would be picking an empty folder. Then you clone OpenZeppelin inside that folder. Enter the folder and run npm install. The opening the packages so on is just to give a look to study. And then you run compile to see if it is working. If it is working, everything is correct.
I have a problem testing my contract.
The test? Or did you compile? It
Yeah,
worked?
with hardhat.
Okay, that's the next step.
Problem. I think this is either version, but I'm getting this error, and I can get the signers from my contract. It's saying that get address is not a function, and I think this is the line, either that signers. I don't know if there's any breaking changes between either versions.
This is the next step in the tutorial. Okay, don't worry. Probably need to use a TypeScript project there.
Oh, okay.
Okay.
I think I installed it, and it installed itself in the user local bin. Is it fine if I just bring it to the desktop?
Yes, but yeah, you just need to have access with that user. Are you able to do like npm? Like
Yeah.
npm?
Oh no, I have to try it still.
Okay, see if it works.
Yeah, but I tried to run one of the last files, and it's just like saying run the train 6 about it. So I think it's working. I mean.
Okay. Are you able to compile, for example?
Yeah, I just did this one. But,
NVM, no, npm.
Yeah, and it's saying to me nothing to compile.
Okay, so you have already compiled. Great.
Yeah.
Nice. Okay. So people, let me demonstrate what this kind of tool can do for us. It is a sales pitch. I need to convince you of that first, right? Otherwise, you are not going to invest your time into learning it. So, let me demonstrate what this tool can do for you. The next step would be running a test inside the repository. The maintainers of OpenZeppelin have already coded token ERC20 here. They have already coded a lot of tests. Those are scripts made by devs that are meant to check all the scripts made by all the devs or the same devs. Okay? So, for example, one of the things that this test is asserting is that when you ask for a token name, it should have the same name as set in that script. When we have a symbol, it should have the same symbol as set. When we have decimals, should be equal to 18. Okay? Like conformity tests to make sure that everything is working as intended. Okay? It's great to have that in place. And in fact, it can even help you to learn development. It can even help you to architect a new project before actually coding it. In this situation, the tests are given for us. Another person has written that test in the past. And we are going to execute that test with this command, npm run test, and it's going to execute with this parameter. If we look at the package.json, we are going to see that we have a script here for test that is going to use hardhat for testing it. Okay? We could use Foundry for test as well. In this situation, is using hardhat. So let me run this command. And this is an automated test to see if everything is working as intended. Okay? A lot of things, 126 situations that could go wrong being automatically checked here by this test script. Okay? Now let's say we are in a hurry. We want to finish a feature in a deadline because our program manager promised that we would go for the party, and this is the background music of the party, if we ship the feature by Friday. So we just ship it as it was. And then we went here for a file. The file is contract token ERC20, ERC20.sol. Contract token ERC20, ERC20.sol. And then we are going to change the decimals function. Instead of returning 18, we are going to return 42. Because that's the feature requested by your program project manager. It completes the definition of done of a task. Okay? Who uses Jira here? Jira. You mark the task as done, ship, your project manager is cheering, oh, you did it, congratulations, let's go for the party, there is a lot of beer. And then a lot of other things break. How to prevent this? Have you ever broke something into production? Like, raise your hand. I could raise everything, I broke a lot of times. So, if you have a testing suite like this, it can detect this problem. So it's not only for firing people. Okay, let me explain the good part. It's because when you are super worried with breaking all this stuff, instead of going fast and creating your feature, you go studying a lot of other files that other people created. You don't understand the other files. You don't know exactly what you're messing it. So a feature that is 2 hours to develop takes you a week, because you are trying to get yourself positioned in your project, trying to do the correct thing, try not to break other things. Okay, that's a good sentiment to have. When you have tests in place, if the tests are good, if the coverage are good, you can carelessly go and implement your feature, and then you run the tests and see if you have broken other people's code. You don't need necessarily to understand all of the implementations around what you're messing. You just need to make sure to comply to the test scenarios, if the tests are good. Okay? So today and tomorrow I'm going to guide you through doing this kind of structure for understanding what we are building. We are going to test things before we actually implement those. Of course, the test is going to fail. I want to do a feature like this. The test is going to fail. But it's good. Like, I have 20 failing tests. Then I go complete the first feature. Okay, now I have 1 test passing, 19 failing. I do another feature. Now I have 2 tests passing, 18 failing. Okay, it's similar to the TDD methodology, testing driven development. Okay, it is great to using in production. I don't want to force that on you if you don't think that it makes sense. But for learning, for hackathon projects, if you want to quick try out a protocol, if you want to quickly try out the graph, if you want to quickly try out Beetle Guild, some specific thing that you are doing in a smart contract, how that behaves, then you can debug an execution. Was you that asked yesterday about debugging? Or someone asked? Yeah. So with this structure, you can isolate pieces of code. With a extension I can show tomorrow, you can even debug the execution of that function instead of throwing that to the blockchain. So the best way to learn is like this. You try, you break, you hover a mouse over something and you know the variable value. Okay, so you don't need to console log everything. This is going to be super helpful for learning, okay? And also, if you want to keep that, if you want to use that in production, if you want to use that in your working project, even in like Web 2 projects, so doing a TDD methodology can help you in your marketplace, your e-commerce that you are building, your mobile app. Okay, so if you like, the methodology can be applied in many situations. Okay, so to fix that, just go here, 18, save it. Now we can run the tests. And it should have everything passing. Okay.
But you didn't do the fix your boss asks?
That's his problem, not mine. I fixed the code. Okay. Depends who's the bigger boss. If it is the project manager or if it is the quality assurance. Okay. Depends who is more eager to fire you. You appease one or the other. Playing politics. Okay, so before we finish today, I'm going to show you how to start a new project. Mess it up here. It was like that. Bear with me for a while. Okay, it was like this. Okay. So for the hardhat setup, first step, the most important step, creates a lot of confusion. Let's start a new project, people. It is not inside OpenZeppelin. As I said, I'm just using OpenZeppelin for a showcase. It is a model. Okay? I'm going to close OpenZeppelin. We're going to use that later, but I'm going to close this, closed. I'm going to exit this folder, okay? I'm not going to be inside OpenZeppelin contracts anymore. I'm going to exit that folder, okay? And I'm going to start here. I'm going to start in that other folder. I can guarantee you if you do not leave that folder, everything is going to break. Leave OpenZeppelin folders, create a new folder, go for a new place in your machine for us to start this other project. Okay? This is what you are going to do in your hackathon project. This is what we are going to do in the exercise Friday. You are going to create a new project. Okay? Actually, when you use scaffold.eth, that we are going to see Thursday, it also creates a new project for you. You're going to find it there. Okay? Do not mix one project with the other. Okay? So go for a new empty folder set aside in your device. Open a terminal in that folder, or open a terminal and navigate in that folder, and we are going to follow these steps here into the documentation. Okay, so I'm going to open a terminal window here, about half an hour, and I'm going to follow these steps into the tutorial. Different from OpenZeppelin, you don't clone the repository of hardhat to start a new project. You install it with npm, the Node Package Manager. You install one of the distribution, okay? Later on, when we are going to use OpenZeppelin, we are going to use it that way as well. We're going to use it as a package inside our project. But for now, I just use it that as a role model. So we are going to use those commands. Create a new folder. Make sure is a command that might work or not depending on your operational system. If I do this command here, it's going to create that folder for me. It is empty. Then I can change directory for it. it is empty, you see? And if I show the upper folder, they have hardhat tutorial and OpenZeppelin contract. It's not one inside the other, okay? They should be separate. They could be in totally different places as well. You don't need to put one on the side of the other, okay? So here it's empty, and I cannot add hardhat directly to a folder, to an empty folder. The first thing that I should do for adding it with npm is initializing. Okay? You can initialize a folder with npm, with yarn, you can initialize it with bun, with pnpm. There are a lot of different package managers that you can use. I'm going to stick with npm here, but later on you might consider switching for yarn. That is quite quicker, can do cached versions for your dependencies and other cool stuffs. Okay? Scaffold.eth is going to use yarn as well. So it's a good idea until Thursday to have that installed on your computer. We're going to do this command, npm init. Our folder is empty. We're going to do that so we create a structure, a package.json for our project. And it's going to ask many questions. What is the package name? You can just hit enter and pick the default one. What is the version, description, and all of that? Actually, all of this is just metadata. It's not important for your project. You just hit enter on everything too many times, okay? So this is going to create a package.json empty with the name, version, description. All of this is not important for us right now, okay? We just need to have the package.json. And then, after we do this npm init, we can install hardhat as dev dependency, okay? This save dev here, or the dev flag in yarn, is just to mark that dependency as a dev dependency, okay? It's not important for us today. It's not like we are going to push that to production. Okay, it's just that is a special kind of dependency that can be ignored when pushing that project to a server or something like this. It's not going to be important for us today. We can just copy it as it is and put inside our contract, our project. This is going to add a dependency. When we opened OpenZeppelin, we didn't have to add the dependencies. They were given. We downloaded the project with the package.json there. Here, no, we are starting a project from scratch, so we need to add the dependency. Okay? Okay, 73 packages are looking for funding. Okay. If we have a millionaires there or altruists there, consider funding those projects. They are in need. Okay. After you install that, you should have a package.json now in that folder, like ls. The package.json is there. And it's going to have the hardhat dependency. Let me show that for you. I do have the dependency here of hardhat. Okay? So they have picked the correct version and all for me. Now I'm going to use, are you following? We initialize it, we install a dependency, and now we are going to use this dependency we just installed on our initialized project to initialize it again with the contents of the dependency. Okay? So first of all, we initialized an npm project, and now we are going to initialize a hardhat project. Okay? It is unpacking. It is expanding. Okay? It's like you buy a 3D printer and then you print another 3D printer with it. Make sense? Like expanding, unwrapping. So we are going to use hardhat that we just installed with npx, it's not npm, okay? npx is node package execute, node package run, use npm to run, a hardhat with the command init. There are a lot of different things that hardhat can do. Compile, test, coverage. One of the things you can do is init, that you can use it to scaffold all of the files, all of the configurations needed for your project. Okay? And it's going to give you a menu. Do you want to create a sample JavaScript project, or do you want to create a sample TypeScript project, or a TypeScript project with VM, or an empty hardhat.config.js? Okay? You can create your projects with those different configurations. I'm going to suggest you to create a TypeScript project with VM. Okay? Let's go part by part here. A JavaScript project is good for all of the JavaScript developers. The problem is that, like, how many of you are JavaScript developers? 1, 2, 3, 4, 5, 6, 7, 8. Okay? The problem is that for everyone that is not a JavaScript developer, building JavaScript coding JavaScript and executing can lead you to a lot of traps. You build a code, it's not giving any errors at all. You run, and then an error appears. And then you fix, then another appear. And then you fix, and then another appear. And then this can cause a lot of stress, a lot of confusion. Using TypeScript is JavaScript with a lot of bureaucracy. There are a lot of checks, check thing as you code, as you type. And usually we don't like bureaucracy. But in this situation it can help. Because as you are typing, TypeScript is checking. Are you doing right? Forgot a line. You forgot a comma. You forgot to launch. So TypeScript is watching you all the time. And when you commit a mistake, you know that. You don't need to wait until you run the program to discover that you forgot a comma in the line 65. You see? And then TypeScript can do those checks for you. It can be annoying sometimes. Sometimes you just need to appease its ego. But sometimes it saves you of some big mistakes. For the students that are not very familiar with JavaScript, TypeScript can be a good railway, can be a good guide for you to know what is happening. Okay? You can hover your mouse over something and see the type. Okay? It can help you a lot. Now VM. So up to 3 months, 4 months ago, creating a project with TypeScript was normal, and you used a package called ethers. It is a common package for building things with Ethereum, smart contract, and all. And all of the documentations of hardhat consider that you are using ethers. Okay? So why to use VM? Why I'm making things more difficult or what? Because scaffold ETH, because all of the protocols like MetaMask, like Uniswap, 1inch, the Graph, or whatever, when you are building projects with them, they provide SDKs, they provide boilerplate things for you to use that use VM instead of ethers, that use WAGMI, another component that uses VM. And this is very painful, this is very stressing because you have two different things being developed at the same time parallel to each other. Yes, but again, I'm here to help you. I'm here to try and ease this pain. We are going to start with TypeScript with VM, so you already get started on what everyone is using at the moment. Just consider that sometimes when you're going to read the documentation, you're going to find some weird stuff, okay? And I'm here to try and ease in this process. Okay, so those are the options. This last one is hard mode. You have to figure out by yourself. So those three create more structure for you to begin with. You can hit enter on all of those options when they give you. So these are the steps that we are doing. We follow those steps. We pick create a TypeScript project with VM at the last step. Then we hit enter and enter and enter. And after all is completed, we are going to open the project in VS Code. Okay? Important. The last thing that the command line asked me is if you I wanted to install the project dependencies with npm. Okay, you saw that, right? Yeah. Not always this happens. In Windows or some versions of Mac, they don't ask this. So you need to run npm install after. Or just like if you're using yarn or bun, you need to do yarn install or bun install after, okay? Bear that in mind. If you are executing, see if you can hit this line and if it works. Okay? If not, you have to install it manually. So here, what happened is that it installed 220 packages and created that project structure for me. Let me open that in VS Code. So this is the project structure. We have contract, scripts, and tests, and those configurations files, the package.json, hardhat config.ts, that is needed for running everything here, and tsconfig.json, that is a configuration for the TypeScript server to work. Okay. What is this TypeScript server? Let me open a script here. Don't worry about the script itself. Is that I'm going to start typing something like banana.peel. So in JavaScript, it wouldn't give an error. Or it would give a different kind of error, but I could eventually pass. Because banana is of type of any, and we cannot find this banana here. So this is what TypeScript can help you. It can help you avoid some mistakes. Oh, I thought we had that function, but it can stop you from doing that. Okay? So when you install it, you have a script here, test, that is not going to do anything. Okay, so it's different from the OpenZapney. The way for you to test it is not npm run. Okay, no, don't do that. That only worked for OpenZapney. What you need to do is npx execute hardhat. We have already initialized, so we're not going to do it. And compile. Okay. Or test. Okay. Those commands, they work. npx hardhat compile, for example. So it compiled one Solidity file successfully. What Solidity file it has compiled? This Solidity file that is inside the lock.sol. Okay. See. Give a look on that smart contract for a couple minutes, 2-3 minutes. Try and figure out what it's going to do. Don't need to say now. Try and figure out what it's going to do. There are quite some complex things here that I did not teach yet, but give a read. Let's see if it's super clear for you what it's doing. Spoiler, it's not going to be that clear, okay? I'm going to suggest those. So, there are two extensions that I'm going to suggest. One is Solidity, that you have two versions, one from Juan Blanco and the other Solidity from hardhat. Both work. Okay? I use Solidity from hardhat, the second one, that provides me some more comments, some more bugs as well. And I'm going to suggest another for tomorrow for using those tests here that we're going to see tomorrow, okay? But even if it's all right, you can read as well what's going to happen. So we have a weird constructor, we have a weird thing at line 11. Line 8 and 9 is good for us. A weird thing on line 20. A lot of weird things on line 23 inside this function, right? You agree that it's not so easy to read, right?
So basically this code lock an amount of money and when the times come you can...
Yeah, it seems like, but it's not that clear. We need to work this out. But What if we run this command, npx hardhat test? Give a read here. When we deploy, what should happen? And when we withdraw, what should happen? Quite human readable, right? You could send that for your project manager, for your CEO, for your client, for your friend, and it does quite a good job on explaining what should happen on each of those occasions, just by how it's telling. When I deploy, it should set the write and log time. I should pass a time as a parameter, 1 year, 1 day, 1 month. Should set the right owner. We just did that a while ago, so only my address can withdraw. Should receive and store the funds that I sent to it. So hence we have the payable for it to be able to receive things. Yes, a constructor can be payable. And it should fail if the unlock time is not in the future. So here, I'm passing an unlock time. If it is less than the block timestamp, we should revert. Okay.
How can a constructor be payable? So when you deploy, you pay some time.
Yeah, so I deploy the contract and the money gets stored in the contract that I'm deploying. See? At the same time, the same transaction. I don't need to deploy and then fund. And in the withdrawal, the same thing. We have the plain text explanation here. So if it is called too soon, it should revert. Let's give a look. When I have withdrawal, and if the timestamp, it is requiring that the timestamp is higher than the unlock time. If that doesn't happen, you can't withdraw yet. It's going to revert. Should revert if it's called for another account, if it's not the owner. Okay, so I'm requiring the MSG sender to equal to the owner. Oh, you are not the owner. Okay. Should emit an event. Okay, so it is emitting that event here. It's not important for us, but now you know that events can be emitted somehow. I guess we are not going to cover that in this bootcamp, but this is just a data structure that doesn't get stored in the blockchain. It gets stored in the node like a log, execution log of that. And then we have a transfer to the owner all the balance that is stored inside the contract, this contract. Remember I told you about this. I'm picking out the balance and transferring to the owner. That is the person here on the construction. Okay?
I guess the answer would be no, but if I have different function with payable, all the money of different function come in the same smart contract, not in different zone of the...
If I have 3, 4, 5 functions inside the same smart contract, all the payables are going to be stored in the same safe, in the same account. See? But different smart contracts have different accounts, different money on that. Okay? See how the test can help us to understand the code. It can help other people as well, all the developers, all the clients, your project manager, your quality assurance. Okay. Sometimes it's much better than doing comments, because comments can be outdated. You could comment a code, and the code below is doing totally different from the code you commented. Okay. Like this function is going to sum 1 plus 1, and then there is 5 plus 9, because you changed that and forgot to change the comment. That's very common. With tests, no. If the tests are properly written, it is impossible to not comply to the tests. So the tests are going to explain what your code is doing at some extent. Okay. So we are going to see, I guess tomorrow, we are going to see more about this test structure, how it works, how the syntax work here, all of those scenarios, how they are being built. But I guess today we have enough time to pick how this script is working, okay? Not line by line, but the structure of it. This script here, let me clear. This script is stored on the script deploy.ts, and we can execute it doing that. npx hardhat run, and then I pass the path for the script. And it's going to output things to my console. Okay, so this is probably the common dev experience that you have when you develop with other languages, with other stacks. You run something in your terminal, and you get an output to see if it worked or not. Okay? So how this is happening here? We have a function, main, that is doing a set of operations and logging something at the end. This function could be something like this. Console log dot Copilot is playing games. Hello world. Okay, so if we run that, it's going to do exactly what we coded. Okay? So it's just a script. The syntax could be different, async, whatever, import, and all. But believe me, it's just doing what it is coded for. Just doing the instructions that we put on each line. And the tools that I'm presenting you, they have, even if I'm working in my computer, in my console and all, they have a strong link with what is happening in the blockchain. Because look, I'm consoling log here that I deployed this locked amount of ETH with the unlock timestamp that, deploying to that address. Okay, so what if I change this contract to require that the MSG value should be higher than 10 Ether, for example. This safe is only going to work if you play big. If you are a small fish, this safe is not for you. Look for another safe. As soon as I do that, this deploy.ts is trying to deposit 0.001 ETH. I've changed the smart contract. I didn't deploy or whatever. As soon as I run this script now, it now gives an error. RPC error occurred, a lot of bytes is vomiting a lot of information for us, and unknown RPC error occurred, but that's not important. The important is we changed a solidity file, that is something supposed to be on-chain, deployed and all, and we could reflect it instantly in the script that we are running. Tomorrow we are going to see that we can do that as well into the tests. And you have this test structure. Look, reverted here because it was trying to do this and this error occurred. Okay. This is super helpful because the things that you eventually get right here into the TypeScript, here into the scripts and the tests, they can be copied and pasted, they can be replicated into the front end that we are going to use with Scaffold ETH. So for example, if in your front end, let's say your hackathon project is doing a lock, a safe, for you to store money or for you to save money for retirement or whatever. Once you develop the script to do that in your computer, you are testing this and the smart contract is working properly, you can copy those same lines with small adjustment using those same tools with those same primitives. And let's say you want to click a button and deploy. So this is the command you want to copy. Let's say now you want to click on reload and display my balance. So this is how you get the address of the contract and your balance there. Okay? All of the tests that are written here, all of those tests, for example, should receive and store the funds to the lock. So I expect public client get balance of this to equal the lock balance. So this is how you get the balance. I didn't even explain the VM part for you yet, but you know that line 67 to 69 is how you get the balance from a person that I'm checking here. Okay, so if you ever need to implement that in the front end, you can copy here. You know that it's working. You can copy and implement that so long you have the correct packages installed, like VM, like hardhat if you need, and the correct instructions for it. Okay? Good. So we're going to do most of it tomorrow. Just giving an explanation. And in Wednesday we're going to do that inside the front end. In Thursday inside the front end. So creating a UI, styling it, creating the buttons. When you click a button, you should call a function, the smart contract, and all of that. Tomorrow, we're going to learn most of the back-end part of doing that in scripts and tests. And Thursday, you learn more of doing that into the front end. Okay? Good? For today, this is it. Thanks for all.